Again, excuse me. Again, welcome to our lectures on matrices. This is Precalculus at New Jersey City University. And our topic again is matrices. So again, in this session, we're going to learn the basic concept of matrices. For example, what is a matrix, how to add and subtract matrices, also how to find the transpose of a matrix, and how to multiply a matrix by scalar, and also what is a scalar. So matrices are classified in terms of number of rows and columns that they have. So example here is that we have a matrix that's just 2 dimension. So a matrix is more or less like a table. So in this matrix, we have 4 columns and 3 rows. So, and the size of a matrix, the rows come first before the column. So the size of this matrix will be 3 by 4 because we have 3 rows and then 4 columns. So matrices again are classified in terms of the number of rows and columns they have. In this case again, we have 3 by 4 because it's 3 rows and also 4 columns. So this is an example of a matrix from the first element A11, which means A is in position 1 row and also position 1 of column. So 1, 1, all the way to AMN. So the size of this matrix will be M by N. Again, the first value is the row and the second value is the column. So 2 matrices are said to have the same order. The same order means the 2 matrices have the same size. So for example, here we have matrix C. We can see that the size is the number of rows by the number of columns. So it's 2 by 3. But in matrix D, the number of rows is 3, the number of columns is 2. So it's 3 by 2. So the 2 are not the same, or they are not in the same order. So C is 2 by 3 and D is 3 by 2. The first value is the number of rows and the second value is the number of columns. So here we say the numbers in matrix also are called the entries, or sometimes we call it elements. They are called elements. A square matrix means the size of the matrix are the same. Let's say the number of columns is the same as number of rows. So a square matrix means 3 by 3, 4 by 4. So this is an example of a square matrix. It's 3 by 3 because we have 3 rows and also 3 columns. And this is an example of a row matrix. A row matrix means you have only 1 column and the number of rows, it depends. It can be as many as you want. So in this case, I have 3 by 1. So it's called a row matrix because you have only 1 column, but the rows can be as many as you want. And also column matrix means the row is 1 and the column can be any amount. So here we also have a square matrix here. And this matrix is called 0 matrix because all the elements are 0. The second one is not a square matrix, but again, everything is 0. So the size is 2 by 3 and is 0. The next one is 3 by 4 and all the elements are 0. The goal here is we should know what is a 0 matrix. A 0 matrix means all the elements, the entries in the matrix are all zeros. So when the columns and rows of a matrix A are interchangeable matrix, here we say that we are doing what we call the transpose, which means I change the rows now become the column and the column becomes the rows. So here we say when columns and rows of matrices are interchanged to create another matrix, the vice versa, we say that A and B are transpose of each other. I use A transpose A to get B, and I can use B transpose to get A. So which of the elements is represented by A32? Remember, 3 is number of rows and 2 is the number of columns. And if the matrix name is uppercase A, the element will be lowercase a. So this means I'm going to the third row and then the second column. So the answer should be 8. We will check the answer soon. Now another question is A square matrix? Yes, it's a square matrix. This is the number of rows is the same as number of columns, so we have 3 by 3. Now we should find the transpose of matrix A. It means we should turn the column to rows. So it will be 137, 048, 323 across. Now another question says, does A equal to B? A equal to B, don't know, we miss by one value. So the third row, third column value is 3 in A. The third row and third column value is 4 in B. So they are not the same. So this is the answers, as we said earlier. A32 means the third row and the second column. And we have a value of 8. The second question we said is square matrix 3 by 3. And we transpose again A by looking at this result transpose of A. It means A is 103, then 342, then 782, which is from up down. So what I'm doing is I'm just turning the degree, 90 degree. Here A 3 by 3 is not the same as B 3 by 3 because of one value. The value in the position 3 by 3 is not the same for the other one. So next we do addition and subtraction of matrices. Now before we do addition and subtraction of matrices, there's one condition we have to meet. Both matrices have to be the same size. The number of rows and the number of columns have to be the same. So here we say if two matrices have the same number of rows and columns, yes, then we can add the matrices, or we can also subtract the matrices elements. So this is an example. I have A plus B. This is correct since the sizes are the same. The number of rows for A is the same as number of rows for B. Number of columns for A is the same as number of columns for B. So they are the same. A and B can be added. And later we get it down. So in addition and subtraction of matrix, A plus B is the same as B plus A. This is also known as commutative law of addition for matrices. The matrix B is called a negative of matrix B. And each element of negative B is negative of corresponding element B. So here we have B equal to -1, -2, 2, 0, -3, and 1. Then negative B will be what? We just change the sign of all the elements. So -1 become 1, -2 become 2, 2 become -3. And we know 0 is 0. Then -3 become +3, +1 become -3. So the transpose of B will give us what is on the right, -B. This is another example. We have a table 3.2 which summarizes the actual and also projected US dollar values in billions of US export and also import of pipeline natural gas with Canada and Mexico, of liquefied natural gas with other countries selected here. So here they selected 3 countries for us, Canada, Mexico, and other. And we want to know the total export, and we can see the values, and then total imports of all those resources to different countries. So here, the solution is that we get the values for A and the values for B. Then we find the difference. So that will be the answer here. Now, scalar multiplication means we are multiplying one value to all the elements. So, for example, if I have A, CA will be C times A11, A12, A21, A22. So this is more or less a scalar multiplication. One value, which in this case is C, we multiply by all the elements. And this is a good example. We have a matrix A, which is given to us, and it's 3 by 4. We should find 5A. 5A means we're going to multiply 5 by all the terms in the matrix. Negative 2A also is the same thing. So we can see 5 is multiplied by each term, and this will be the final result. Now, the second is negative 2A. So multiply negative 2 by all the elements in the matrix, and that will give us this value. Again, thank you for this short lectures on matrix, addition, subtraction, and scalar multiplication. And also we went through the definition of a matrix. Thank you. Bye.